TATV's Insight, and we're taking a deep dive into the world of in-flight connectivity. And in-flight connectivity is usually performed by geostationary satellites 35,000 kilometers away. And there's a new player in town, that's OneWeb. They don't have one or two satellites, they have hundreds. Let's talk to Ben Griffin about what they have in mind.
So last week was a milestone for us. It was our 11th launch, and we're up to 358 satellites now, which is well over half of the 648 required for the initial constellation. Because it's low Earth orbit, they don't have the same life expectancy as our geostationary cousins, which are sort of 15, 17 years, something like that. Low Earth orbit satellites tend to last a little bit less time up in space. So we're already thinking about generation 2, how that, what sort of capability those satellites should have, the sort of coverage areas, capacity, and all those sorts of things. So it's really, rather than a generation 1, generation 2, it's a long-term evolution of the constellations that we will keep up in space. So the OneWeb service launch, there are a number of ways in which we'll introduce service. So later on this year, mid-November, we're planning to have commercial service introduction, CSI 1, which effectively provides service above 50 degrees north, so Alaska, Canada, the UK, some of the Scandinavian countries. For fixed applications, we'll be able to start using OneWeb services then. And as we complete the launch, the constellation, we'll introduce other CSI variants, but the end goal really is to get to mid-22 when all the launches will have occurred, and we'll have full commercial service introduction by the end of 2022. The aviation service launch is a little bit after the full constellation, so early part of 23. There are nuances, changes we need to make to the network to allow that level of mobility and capability. We're busy building the terminals at the moment. We're busy appointing our distribution partners, and we're announcing those very, very soon. So in terms of when people will start to enjoy using OneWeb's groundbreaking services on board aircraft, we think about halfway through 23, and then obviously beyond that for the years to come. I think it's fair to say there's a whole variety of solutions and services out there today, and I think it's fair to say that globally there's no consistency. Some of it's okay, some of it's pretty poor. I don't think much of it is really, really great, or certainly not in expanded areas of the world. So what we're doing is bringing a truly global coverage to it without any gaps, significant amounts of bandwidth that the likes IFC, in-flight connectivity, has never seen before. And couple that with a low latency service as well. Might not mean a lot to a lot of people, but it means web pages will be loaded fairly instantly. Applications that are being designed for use on 5G won't time out. You'll be able to use cloud applications, these sorts of things, which we all do quite happily on the ground, but as you experience slower things in the air or remote locations, they just tend not to work so well. So we'll see greater user experience. We'll see a wider range of applications being deployed. We'll see better value to the passengers, and even more applications for operational purposes for aircraft, airlines, crew, and these sorts of things. So we're really bringing a level of value to in-flight connectivity that simply hasn't existed until this point.
On that point, though, what sort of download speeds can we expect to see in aircraft?
Well, there's a number of ways to answer that, but the network itself, the usable network itself, has over 1 terabit per second of capability. The total network capability is 4.5 terabits per second, so it's a beast. The spot beams have capability of 450 megabits per second or thereabouts. The limiting factor, initially will probably be the terminal, the modem, something like that. But we expect hundreds of megabits per second delivered to an aircraft. And we all know the way that passengers engage and use things, they don't all draw at the same time. So we fully expect to allow or enable passengers to really do whatever it is that they want. We don't see this funnel of demand versus supply, which is what we commonly see today, being a restrictive factor. So we really want to encourage people to do what it is they want to do, and that in turn will lead to passenger satisfaction, airline satisfaction in that they're selecting a technology that they can really use and develop into things that can really broaden their passenger and their operational experience. The Middle East is a really important market to us because these are airlines that aren't new to this. They know exactly what they're doing. Very ambitious digitization plans in terms of the whole airline environment. A group of passengers who are used to having and depending on a level of connectivity. They introduced a lot of them seat-back phones, even fax machines back in the day through the GSM, and then Wi-Fi and live TV. So all of this suite of stuff, a lot of the carriers and their passengers have become used to. So when we have discussions with airlines in the Middle East, for example, they know exactly what they're looking for. And when we tell them what OneWeb's capable of, we spend quite a lot of time picking their jaws up off the table. It's really quite an interesting reaction to see, you can really do that? And yeah, we can really do that. That's what we're building. And it's pretty much the same reaction across the globe. You know, it does feel very much like this utopia is coming in terms of in-flight connectivity. And we're really excited to be a part of that revolution.
The world's a big place. So what about Africa and India and the oceans?
Well, the way OneWeb's constellation is put together is that we do actually cover the entire globe. So you mentioned Africa and India specifically. There's the same amount of capacity there as there is all over the rest of the globe as well. What that also means, we're able to cover all of the oceans and also the polar routes. So when aircraft flying from the Middle East to the US, for example, flying over the North Pole, that is now an area that will be covered with in-flight connectivity. So we're really pleased to be able to offer really viable solutions for airlines in Africa, South America, India, these sorts of places that are a bit stumped for choice at the moment. What we're bringing is a whole load of value, which I don't think has really truly existed in the connectivity space before. So every economic benefit or perspective from an airline is very different. So to ask about how things cost or how they stack up is perhaps not the best way to approach it. But bringing real value, making sure we're delivering to airlines and their passengers and their customers and their stakeholders something that they actually want rather than what it suits the supplier to provide to them is absolutely key. And enabling a whole new level of capability from connectivity is about more than just a cost factor. It's really an enabler.
So, Ben, you've got the satellites sorted out, but you're also going to need terminals and antennas as well. So how does that work?
So by the nature of low Earth orbit satellites and the speed at which they move around the Earth and the multiple beams per satellite and the amount of switching and pointing that needs to go on with these with the terminals, the antennas, to make sure they hold these connections, it's obviously not viable to have mechanically steered antennas. They would A, not tune quickly enough, and B, even if they could, they would probably break even more frequently than they currently do. So we're looking specifically at ESA's electronically steered array antenna capability. This is new technology, so this is a challenge in itself, is how do we do that? How do we certify it? How do we bring it to an aviation community that's very hungry and very ready for all this LEO technology? But harnessing it in such a way that an antenna can bring all of that power down to an aircraft and delivering it is quite a new thing. So ESA technology is absolutely key to OneWeb's success. We are working with a number of, and there are quite a few of them, a number of ESA technology providers, and accelerating the path to be able to A, comply, or rather be compliant with our network, but B, also to integrate these terminals to make sure that they're airworthy and capable of being either retrofitted or line fitted onto customers' aircraft.
So what is OneWeb's long-term plan once you get past phase one of the satellite launches?
Well, stage one, or the initial constellation takes us to a point where we have a groundbreaking IFC service. Stage two, or generation two, or stage two of the evolution, if you like, takes us into a different ballpark. A step change again in terms of capacity. We're designing already what we want in terms of payload and capability on that constellation. And you'll understand if I don't tell you exactly what those things are for competitive reasons. But very much, where do we go from here? What does the passenger of tomorrow want from connectivity? Because it's not about me. I know what I like to do with connectivity. But gamers, people who are growing up now, coming through school, who will be the travellers of later on this decade and into next decade, what is it they want to do? What capability do we need to make sure that we provide to those people who frankly get a bit sweaty if they're not connected?
Thanks, Ben. If you want to know anything about what's going on in the aviation industry, go to our YouTube channel at TATV. This is Steve Nichols at OneWeb in London.